All right, let's recap what you might have gotten on this. Number three, the population of Denton is growing at a rate of 3 people per day. So, population, I guess we'll just use a P for population, probably a capital P. So, maybe something like a DP dt. All right, there's the weather report. It's growing, so it's going to be a positive. The number is 3. And the units are people per day. Maybe people is ppl. I don't know, ppl. And then day. Something like that. All right, so your variables might be a little bit different. Maybe you said people was just p. Maybe you wrote out people. Who cares? All right, number 4. The height of a tree is increasing at a rate of a half a foot per day. Height in geometry, we use it as an h. So dh dt. Increasing is a positive number. We get a half, and then our units are feet per year. All right, now the next thing that we're going to do is we're going to go in the opposite direction. We have the rate, and then we're going to try to translate that into some words. Because usually what happens is perhaps I have done all the calculus, I've plugged in my numbers, I've solved for the rate that it was asking for, and then I need to interpret my answer. Okay, so that's what we're going to do here. Translate the following symbols into a bunch of words, one of which is the word rate. And make sure that you highlight, maybe in italics, maybe you bold it, maybe you throw some shadow behind it or something like that. The word rate should be in it someplace. Okay, so we have on number 1, ds dt is equal to negative 50 meters per second. ds, what do you suppose s is? And it is in meters here. So I think S is talking about, well, here, look at the stuff that's underneath it. You got a V, dV, dt, and a dA, dt. I think this is position. It's distance here. So I'm going to say the distance, who knows what it is? Maybe it's a particle or something. The distance is decreasing. Here it comes. At a rate, highlight it. There, it gets 3 levels of highlighting. At a rate of 50, don't put decreasing and then throw a negative in there. That would be silly. At a rate of 50 meters per second. There you go, right? So if I had that ds dt is equal to negative 50 as the final answer after I'm done with my related rate problem, then I would interpret it like that in a sentence. Number 2, dv dt is equal to 11 feet per second. So what the heck is that? That's the velocity. The velocity of a particle, let's say, the velocity is increasing. Well, what are you doing? Increasing at a rate, I'm going to underline it this time, of 11 feet per second per second. You can write it like that, or, it's acceptable to just write per second squared, of course. All right, and then the last one that's on this page before I turn it over to you for you to try a couple of them. dA dt is equal to a negative mi, I'm thinking that's miles, and seconds cubed. So what is the a in this case? I do believe that is the acceleration. It's negative, so we're going to say that the acceleration is decreasing at a rate of 2 miles. Pretty sure that's not how you spell that word. Miles per second per second per second. And I'm going to be pretty lazy about that and just put per second cubed. Okay, so I have a few of them for you to try, all right? So we've got number 4, it's dc dt. You'll have to try to figure out what the heck the c is. ds dt on number 5, dA dt on number 6. Hey, but wait, there's more. On exercise 2c, you got a dr dt, a dVdt and a dHdt. So again, translate those vocally, if you will, into some symbols. No, into a sentence. That's right. And make sure that you use the word rate in there.